At this time, let's begin today's event. Solve your optimization problems like the pros. I would now like to introduce your first speaker for today, and that is Oliver Bastert. Oliver, you have the floor.
Okay, thank you, Jessica. Good morning, good evening, good afternoon, everybody. My name is Oliver Bastert. I'm in product management for optimization with FICO, and I'm joined by Horia Tippy, who is also working in product management for optimization in FICO. Briefly, the agenda of today is 2 case studies. What are the pros using Express for? Second part is an introduction to Express, which also contains an update on what we've introduced in the latest Express 7.6 release. And from then on, I would say the true fun starts. We're showing a lot of demos, a lot of software, a lot of code to give you the best impression we can give you on Express and the different components of Express, topics there are modeling complex problems, and how to actually rapidly build applications with Express. And at the end, we will close with a Q&A session. So Express turned 30 this year. We're probably the oldest optimization product in the marketplace, as well as the first one to ever run on a PC. Which companies are using Express? You might have seen in the invitations that American Airlines is one of our large clients. And what are airlines using optimization for? They have been kind of like the early adopters of optimization in the industry. It's used across the whole part of these organizations. They start planning their networks, their fleet and their facilities. Big focus area is actually around scheduling flights and crew. You might have heard about crew pairing, rostering type problems. Big focus area, and also an area where Express is used excessively, not only at American, but also with a number of OEMs and other airlines directly. A topic which becomes more and more popular in general is revenue management and pricing, and again the airlines have been one of the first to use optimization technologies for that. Another well-known user of Express is the NFL. So they are scheduling or creating their schedule on an annual basis. And the very easy goals are, how do I get the most out of the schedule for my spectators? How do I get the most television money out of this? But also I have to look at other constraints like stadium availability, competitive impact, in particular with respect to the travel schedules and other constraints. And that's a solution which is based on Express and carried out by a partner of ours. So that's the kind of clients which are using Express. We also have a well-spread partner network, starting from small consultants over to big software companies embedding Express into their solutions. So what is Express? When you have data and you want to start modeling your optimization problem, you need to do this in a certain way, and we propose a way to model your problem using a scripting language, and that's called Moselle for Express. Once you've done that, your model can load the data, and the next step is that you need to optimize this problem. We're doing this using our optimization engines, which are split into 3 parts. The optimizer, which contains the core engines starting from linear programming over mixed integer programming and quadratic programming type problems, then nonlinear optimization, and also constraint programming. Nonlinear was a relatively recent addition with the 7.5 release in April. I will go a little bit into the details about this as well. And then once you've optimized, or once you've set up both of those, the goal is really to gain insight into your business problem. And we are offering with Express a rapid application development framework, and I've called it not rapid application development, but just a rapid application framework, which is called Express Insight. The key point really is if you have a model and you drop it into this application framework or container, you pretty much instantly get out of this an usable application with a UI attached to it, but you will see this later on during this presentation. What is the core functionality of each of these components? As I said, Moselle is a flexible, modular, and very easy to learn scripting and modeling language. It comes with a development IDE, and it contains a number of data connectors, spreadsheets. We've improved on that recently, so it's now available not only in Windows, but also on Linux and Mac OS. We have a new XML driver. We connect to about any database. We've added Hadoop support, and also Moselle can call out to web services. We have distributed modeling and solving capabilities. Again, something you will see today. Moselle pre-compiled your code, so it's pretty much like Java there for efficiency reasons, but also for IP protection reasons, so you can share these pre-compiled binaries with others, and they can't see your IP. For all of the components, it's true, they come with a full set of APIs, so you can connect this to your systems in any way you want to. Then Optimizer, it's the core of the offering. We offer high-performance solvers starting from linear programming, mixed integer programming, quadratic programming, all of the combinations you can think of, going up to mixed integer, quadratically constrained quadratic programming. Again, a new addition are the second-order conic programming engines and mixed integer second-order conic programming engines, and then nonlinear programming and constrained programming. So that's truly the broadest offering of high-performance solvers within one offering in the market. And for you as a user, the benefit is that no matter what optimization problem you have, you can use these solvers, or you can decompose your problem into one or two of these problem types and solve them very nicely within the Moselle environment. We not only look for out-of-the-box performance, we also give you a lot of freedom and flexibility to interact with the solvers and to tune the performance to your needs. We support multi-core, multi-CPU machines, parallel processing. It's a big topic, and we also have automatic tuning. And again, a full set of APIs to interact with this technology. Then on the application side, we can have a full scenario management and a data repository which can store these scenarios, your optimization scenarios, so you can easily create them, you can compare them, you can do what-ifs analysis, understand trade-offs and sensitivities within your optimization model. It comes with great data visualization and also result analysis capabilities. It's a full multi-user application which allows you to collaborate with your colleagues around your model. It works in a web browser and a rich client, and it also works on premise and in the cloud. So there's basically no limitations from any side of that. It's built on a very robust enterprise architecture and allows you to host any projects from very small to really large scale. And again, if you fancy to embed this into your enterprise or build applications on that yourself, you can use our APIs and connect it easily. The next thing I want to briefly introduce is more a teaser for now. We have announced our new FICO Analytic Cloud a couple of months back, and shortly it will be available to a very broad audience, and just to give you an idea what this is about. So what we will offer there is analytic applications and analytic tools which you can either buy, consume, but also contribute to. And with our decision management platform, which is the heart of the FICO Analytic Cloud, you are able to build your own decision management applications. What does this mean for optimization? So focusing on decision management platform, the view is that you get a FICO Application Studio, which is a rapid application development studio. It also comes with great data visualization and reporting capabilities. And in the middle, you see we have decision modeling, analytic modeling, and optimization modeling capabilities within decision management platform. So you can really build very complex applications which use predictive analytics, for example, in combination with optimization, and make them available on the cloud to be used by yourself or sold and being reused by others. So you will hear much more of this in the very near future. Coming now to one of the latest additional features within Express. This is Express Nonlinear. We've been looking at the nonlinear space for quite a while, and half a year ago we launched Express Nonlinear. Why did we do this? Well, we found so many interesting nonlinear problems in our world, so starting from pricing, portfolio optimization, risk management, all these problems can be solved best using nonlinear technology. We're using nonlinear stuff in our own predictive modeling engines for nonlinear least squares fitting, but also we have great experience in the blending and processing industries with our nonlinear engines. So what we decided to do, once we looked at the market again and saw an increasing market demand, and also that the technology really has improved over recent years, that we looked at what we have already. We have Express Moselle, which is a great tool for modeling, and when you go into nonlinear world, you really need a good modeling language because your models become rather complex. We have 12 or 13 years experience with first order nonlinear solving, which you use for blending problems with Express SLP. And then we created a partnership with the best-in-class second-order nonlinear solver company, which provides the solver K-Nitro. Those two components together with our great developers developed the today benchmark for nonlinear solvers. And so within the Express suite, you have now this capability as an integrated component. What are kind of like the highlights? We auto-select algorithms for you. So you can just model your problem, throw it in, and we find the best applicable algorithm. For some models, it might not be a general nonlinear model. It might just be a QP, so we can use a much more efficient solver to solve the problem, but you simply don't have to care so much anymore. Computing derivatives is a big topic for nonlinear engines. We have written them from scratch, completely new, and we are very competitive with probably the de facto standard for this, the ample code there. We can extend our nonlinear models by user functions. So although nonlinear is rather broad in what you can offer, you can't model everything in nonlinear. So for example, a chemical process doesn't fit into the world of nonlinear constraints. For that you can embed simulators, and we use those simulators for deriving derivatives for your simulation. So that's also very easy to do in Moselle. We provide all of this through the Solver API. So if you We recommend that you use Moselle, but if you want to use something else, you can use this through the Solver API. And we've completely rewritten our nonlinear interface, which is now very intuitive and allows an easy approach to nonlinear modeling. Then on the benchmarking side, so benchmarks are usually shown, the smaller the better. We have also ranked the problems by level of complexity. And when you look at it, going from linear programming over to MIP, quadratic programming, and then to second-order conic programming and mixed integer second-order conic programming. Remember, that's our new solver, and then to the nonlinear solver. That's how the complexity increases. We've taken the numbers from Hans Mittelmann's public benchmark site. So you can clearly see that Express is very competitive through the whole range of problems, and it's clearly leading on the more complex ones. From there, I would like to briefly come to an overview of our rapid application framework. That's what you're going to see a demo of in a couple of minutes. What was important to us? So you've done all the hard work. You've created your model. You've worked with your optimization engines. You've got the data right, and well, then you're often stuck. You copy and paste your results into Excel probably. You create some charts. You do your presentation, but this is not an application. Why don't you really have a way to quickly get from your model to an application? And that was the first driver behind Insight. And the other one was we delivered a large number of optimization projects, and we found that a number of tasks we carried out were really repetitive. So with Express Insight, you get lots of the functionality you usually need to implement for every project separately, just out of the box. It's just right there for you. When you've written a model you can turn this into an Express Insight model within very short time. All of this obviously works with the Express optimization algorithms, which give you great power. And one of the features I stressed all through my presentation is that we are committed to connecting to other applications, and obviously we now integrate ourselves third-party components for the best experience. So it's by no means limited. It should be very agile. So our business users should be able to interact with the optimization from anywhere, so not fixed to your desktop, but also from the web, and with everyone, so a truly collaborative multi-user application. What then happens very often in an optimization project is that you've finished your project, it's all well and good, but suddenly your business problem changes again, so you have to go back into the model, change this, that's fine, but then you also have to change your application layer. And with Insight, you get this for free, so your application updates automatically. And you don't need to involve IT, and you don't have any expensive re-implementations. Also core is that the analyst has the ability to modify the application easily. We're going to demo this as well. And again, connectivity is a big thing. Last point I want to stress is Insight works great for small and for large projects. We know that optimization projects often start very small and then increase as you go and might turn into multi-user applications. So we support all of that. And with that said, I would like to turn over to Horia, which takes you through the demos.
Hello, thank you, Oliver. So I'm going to start by giving you a very quick overview of what I'm going to be showing. And then we'll be looking at both the Express Moselle modeling language and Express IVE development environment, as well as the Express Insight business analyst interface that Oliver mentioned earlier. Five different things. First, I'll show you a fairly straightforward linear formulation for a planning model. The second example will be a mixed integer programming model that uses slightly more advanced techniques. Then we'll look towards expanding the complexity of that model by adding the column generation technique. So this is basically a technique that allows you to solve extremely large problems while still using reasonably small hardware. Finally, we'll look at decomposition, a decomposition algorithm implemented within Moselle. And for the last one, we'll go to the moon. So let's wait to see how that works. Okay, first example. I'm going to share my screen. So in our first example, we're looking at a production planning problem that has a time component as well as a resource component where resources for all projects are limited. So what we're looking at is Express IVE. IVE is the development environment for Express Moselle. It's an editor, debugger, compiler, profiler application with a number of facilities for understanding the underlying formulation, understanding the mathematical modeling aspects of building this model. And so we're looking at the Moselle model, which is basically a script together with a declarative version of the mathematical formulation. And in this case, the model consists of a number of declaration sections where we declare the various entities. For example, the expected duration for each project, how many resources are utilized for each project in each period of time, what is the maximum availability or the resource availability per month, so for the entire time horizon, and then the expected value or the expected benefit for each project. Our decision variable, what we're trying to solve for, is which project are we going to be working on during what month. And notice we denote it by X, so X is our unknown here. Quick recap for those of you who aren't familiar with mathematical programming. What we are doing here is we're simply declaratively capturing the problem within constraints, and it is the job of the Express optimizer to actually solve the problem. So all we have to do is describe the problem, and the optimization engine will take care of solving it. Okay, so quick walkthrough through some of the code here. So first of all, we're constructing the objective function. The objective function is the sum across all project and time units of the benefit times whether we engage in that project or not, right? And that's one possible formulation. In reality, you might have various complex objectives that combine several individual components that are assembled into one global object. Another constraint you would have is resource availability. So for all time units, time elements, in this case months, you have to obey the capacity constraint. So notice on the chart here on the right, the blue line denotes how many resources you have available in each time period. And of course, your project and resource utilization has to stay below that line. Also, some basic constraints. Each project starts only once. Then, of course, we want to connect the start variable with whether we engage in a project or not. And then finally, we want to make sure that the project completes before the end of the planning period. So there's no point in starting a project that cannot be finished. So it's a pretty straightforward formulation, and by invoking the function maximize maximum benefit, we're basically asking the Express optimizer to solve our problem. In addition to the basic mathematical formulation techniques here, you also have scripting capabilities as well as graphical visualization capabilities that are built into the language itself. So this allows you to create a very quick Gantt chart or a histogram or a network graph or any other type of visualization where you want to look at the results right away. So compare this with building a model in a modeling language and then exporting the data to something like Excel and then plotting the data. It's pretty painful and time-consuming, and you have to do it over and over. Whereas within Moselle, you can simply add your charting code, your graphical visualization code, right within the modeling formulation itself. Okay, so this is one simple example. I'll walk you through some of the elements within the user interface. There's an output screen, so anything that Moselle writes to the output comes here. Then you'll have a basic statistics screen that shows the composition of the underlying matrix, as well as the LP relaxation and the global search statistics. So how was the solution found, how long it took, etc. You also get a fairly detailed matrix view. So this is built automatically for any mathematical model you might write in Express, and it gives you a summary view of your model. So in this case, your model consists of one objective. It consists of 6 capacity constraints. It consists of 3 link constraints and 3 constraints that basically specify the start of each project. And you also have 2 types of variables. You have a start variables, and there's 3 of them, and they're continuous. Notice the icon here, as well as X, which is basically whether the project is selected or not. And there's 18 of those. Whether a project is active in a particular month or not. And there's 18 combinations, 3 projects times 6 months. And these are binary variables. So this is a neat way to very quickly understand whether your formulation is correct and to see if you've accounted for all the different decisions within your model. Another view is the column view. So the column view will give you essentially an unrolled view of your entire matrix, of your entire problem. So the row view contains every single constraint. Let's take a look at this constraint. So what this does, it's basically the expanded constraint based on the data within your model and based on your formulation. So if we engage in project 1 during time period 4, we will incur capacity cost of 2. In other words, we're going to use 2 resources. If we engage in project 1 during month 5, we're going to incur resource cost of 4, and so on and so forth. And so we want to make sure that this is below our resource limit. Again, this is mainly for debugging purposes and to make sure that you've correctly modeled the problem in the first place. Similarly, if you look at variables, it'll show you for each individual variable, decision variable, what constraints it participates in and what the coefficients are within each constraint. There's also a graphical view, mostly for academic purposes, to help understand exactly what this looks like in a matrix format. And then, of course, you've seen the user graph. The user graph allows you to rapidly plot output that's relevant to your model. Okay, so let's move on to the next example. Next example is slightly more complicated. So here we have a multi-period production planning. And here we're actually implementing several features within the model that help improve the scalability, the runtime, and the solution quality for this specific model. So let's take a quick look at what we're really trying to do here. So we're trying to solve this problem for a time horizon, a given time horizon that has 15 months or 15 periods in it. We're solving for 4 products, and of course we have various complicating factors such as setup costs and other types of constraints. Now here we get to see a bit more in terms of the supporting visualization in Express IDE. For example, the MIP graph shows you how quickly we proved optimality. You also get to see the branch and bound tree. So for those of you who are more interested in the algorithmic aspects, this tree gives you a good idea of how the optimality point is reached. And what you're looking at is a number of different colors. Each color represents a different core. So your CPUs and cores in your computer will work on separate threads. And notice here we have a nice balance between, I have 8 cores here, so we have 8 colors. So we see a nice balance between the different cores. Each one is solving a portion of the tree. Okay, so in this problem, we are implementing capabilities such as conditionals. So here we have a selection algorithm that allows you as a modeler to decide how you want to solve this problem. We're making use of callbacks. So in most modeling languages, you will find that you don't have the possibility to use callbacks. Well, in Moselle you can. So in this case, we have the cut generation callback at each node. So you can actually influence how cuts are created at every individual node within the branch and bound search. That's one example. And of course, you can you can add cuts, generate these cuts in a custom way from within the language itself. Again, contrast this with a typical approach with existing modeling languages where you would have to combine an outside script like maybe a Java program or a C program or a C# program to create this kind of functionality. There's no need to do that with Moselle. Everything is available within the model itself. Okay, next example. Column generation. So in this case, we're actually using another graphical representation feature. This is a paper cutting problem. We're cutting a big roll of paper into individual size sheets, and they are limited in terms of size. So in order for us to find the optimal solution, there are 2 possible approaches. One is to try to exhaustively search all possible combination of paper sizes. But that would take a really long time. It would take quite a bit of memory to formulate the entire problem. Another alternative is the so-called column generation, where we're basically looking for patterns that are favorable. So notice when I click the button Add Column, what we're doing here is we're solving a little knapsack problem where we're trying to fit different paper sizes into the width of the roll. And as I add more columns, more and more patterns will emerge as potentially favorable. And so at every step during this process, we're then resolving the original problem, trying to maximize, to minimize waste for this particular set of widths that are required. right? So notice how the different patterns are plotted here, and very soon, after just a few iterations, we will basically reach optimality where we can no longer improve on the patterns we can generate, and in fact we meet demand perfectly by without wasting really any paper. So the column generation technique, all implemented in Moselle again. The main procedure here is the knapsack procedure. Okay, so function add column. Basically, during when I click the button, this function is invoked, which solves the knapsack problem, and then creates the new pattern, adds it to the problem, and resolves the problem over and over. Again, everything within the language, within the model itself, with no outside code. Okay, the next one is an even more involved example where we're basically we're taking an existing model and we're taking a parallel decomposition approach. So in this case, we have a multi-factory, multi-period production planning model. And so we're taking dance equals decomposition approach, where we take the problem and we decompose it by factory, and then we reassemble the solution while preserving optimality. So what we're doing here is we basically have the master model, and we also have the submodel. And the submodel is fairly simple. It simply solves the problem, solves the model for each individual factory. Notice various, this is closer to a realistic problem, so we have everything from individual costs, variable costs, fixed costs, inventories, stage inventories at different time periods, etc. So the formulation itself for each problem, for each factory, will solve the problem at the factory level, and then the master model will assemble the solution. How does it do that? Well, first of all, it communicates with the worker models through memory. So we're transmitting some information here through a memory type. Then we're basically compiling the submodels. We're loading these submodels for each factory, and then we're running them. And this run function here basically launches the submodels in parallel, allowing for the work to be, of course, distributed across different cores, CPUs, etc. on your hardware. So this type of algorithm, again, typically would require fairly complex programming skills, whereas in Moselle, you just need to understand the fundamental algorithm, which is what are you solving in each worker, and what data do you need to send back to the master model so that the solution is reassembled at the master model level. So again, all of this within Express Moselle. Okay, final example. I promised we would go to the moon. So here's one way we could do that. We're using the Express nonlinear solver, and it actually solves very, very quickly. And what we're doing is we're taking a rocket and we're launching the rocket with an initial speed, and Express nonlinear will compute for us what that speed should be and what orientation we should send the rocket at in order to reach the moon with a minimum fuel cost. Okay, so the formulation is pretty straightforward. We're basically discretizing the flight into a number of different points, and then Express nonlinear will basically compute what the various vectors of forces are on the rocket, how speed well, basically how speed and position will vary throughout the entire flight path, and then essentially ensure that the rocket lands with zero energy remaining on this specific point on the moon. So this is one example. The formulation is pretty straightforward. You don't have to do anything special. You simply include the NLP module. You declare your decision variables. In this case, they are position, velocity, and acceleration at every single point throughout the trajectory. This is the thrust, so basically this is the derivative of acceleration. And then fuel cost is our nonlinear constraint, nonlinear computation, if you will. And this has to do with of course, how much energy is being expended through thrust for the rocket. And then you basically say minimize fuel cost, and that will solve the nonlinear problem for you. You don't have to write any specialized algorithms. You simply have to replicate the problem formulation. Okay, now there's one variation of this. We could take a different trajectory. Suppose we left from another point on the Earth. If we left from the North Pole, for example, we would follow this trajectory. So of course this would work for any pair of coordinates. Okay, now this leads me into the next topic, which is talking a little bit about some scalability considerations. How do we manage these large-scale models? How do you manage parallelism? How can you make sure that your optimization models operate well in production? So here are some quick points I'd like to make. So first of all, parallelism helps. Betting on computers, processors getting faster is a bit of a losing proposition at the moment. We've peaked in terms of processor speed, so we have to constantly think in terms of how can we get more speed, more value, more performance, more efficiency out of our algorithms by leveraging parallel computation. Second, processors versus cores. You are always better off. So suppose you have two types of machines. Suppose you have a machine that has 4 processors, and each processor might have 6 cores, so a total of 24 cores. Now compare that with a machine with 4 different machines that each have 6 cores. It is generally better to use independent machines. So if you want to solve 4 problems in parallel, it is our experience that you're always better off distributing the work across different instances as much as possible. Hence all the examples we've been showing. So if you have access to cheap computing hardware, of which there are many out there, try to construct an algorithm that distributes across those machines. In terms of the MIP algorithm and parallel barrier algorithm, you can certainly take advantage of a large number of cores, and we've had instances where Express was used with up to 80 cores, so that's 80 cores for one process, and that helped accelerate the solution compared to 24 cores by a factor of about 2. So you are getting diminishing returns, but you can go with Express to 80 cores and beyond. I already talked about distributed computing, the 4th point here. So if you can do it at the model level, that would of course help, because then you can decompose your problem potentially across dozens of different machines as needed. And this is where point 5, Amazon EC2, comes in handy. In Moselle, you have the ability to launch an Amazon EC2 instance, execute your Moselle model on that, and then retrieve the results, all programmatically, all automatically. So that's built into Moselle. Finally, the Express Insight load balancer automatically sends tasks across the various optimization services that you might have set up. And the final point, Oliver talked about the FICO Analytic Cloud. When we go live, you will see even more exciting stuff relative to parallelism and taking advantage of distributed computing. So with that, I'm going to share my screen again and show you one example. And I'm going to show you how you can take this model and build an application around it in 30 seconds, and then how you can share these results with your colleagues or with your boss. Okay. Okay, so we'll take a simple Moselle model that solves a project selection problem. So each project, in this case, has an expected value, an expected cost, expected personnel requirement. We have 100 projects. We have a budget. We have a workforce limit, a constraint on budget and workforce. We're making up the data here, so this is random data, and we are then formulating the problem. So whether a project is selected or not is a binary decision variable. We have the budget constraint, workforce constraint, and then we call insight maximize. Okay, so with this Moselle model, we can automatically fire up the Express Insight Analyst interface and create a project that allows us to better understand what's going on here. So let's do a new project. I'm going to pick the 5 minutes code here. Okay, so here we go. Scenario 1, we get to see everything within our project automatically. There was no additional coding. We just wrote our Moselle model, and now it's available in Insight. So here I have a list of all my projects, whether they're selected or not, their expected value, personnel, and cost. I can filter this. I can say I only want to look at the selected projects. So here they are. And I can, of course, further filter or plot any of these results. So suppose I take out the filter and I'd like to look at the overall distribution of expected benefits across all my projects. So with one right click, I can obtain that. Now I'm going to apply the filter again. And let's say I want to create a new project. So I'm going to clone this scenario. Let's say scenario, what if add project. Okay, so I can go to the scenario and I'm going to add a new potential project. Notice I don't have to go back into my model at all. I don't need to fire up Excel. I simply go in here, I add a new project, 101. I'm going to say, let's say it has a value of 90. Let's say it requires 6 personnel and it might have a cost of 60. Okay, so once I do this, I save and rerun. And okay, so let's see, here's my result. Okay, I saved the project and project 101 is now selected, right? So basically what's happening is we can rapidly explore whether the addition of the project will make a difference or not. Furthermore, and this is the final example I'm going to show you, I can now log in as a different user. So we have user Tim here, and notice user Tim does not have access to my project, but that's very easy. We can resolve that by providing access to this user. So I'm going to use the Insight admin interface to take user Tim and enable project 5 minutes for this user. So once I do that, user Tim has access to this project, but no scenarios. So now assume the first user says, you know what, I'd like to share this with my colleague Tim. So I'm going to right-click and say set owner to user Tim. And so now, when I go back and look at this from the perspective of user Tim, I have this project available. I can open it, I can explore the data, I can explore personnel, projects, etc. Right? So everything has been shared across the network and in an entirely cloud-friendly manner. So you don't have to email yourself Excel files and so on and so forth. So this is just scratching the surface. For more details, definitely reach out to us or ask any questions to see if we can cover more topics in details. But what we did was we started with a simple Moselle model, Moselle formulation, and we're now able to do a collaborative business analyst application with no additional code. We're just pointing and clicking and editing values and visualizing results. So with that, I will turn it back to Oliver.
Okay, thank you, Horia. In the interest of time, I'm just showing a very little bit of additional visualization capabilities. So you saw it's very easy to visualize. We are aware there might be very advanced visualization wishes you have, so for that reason we included Tableau. It's a visualization and BI tool into Express Insight. And what I'm showing here is we've created a Gantt chart with Tableau. That's a production planning problem. So you basically have 8 machines, you have a number of jobs, and now you need to decide which job you run on which machine at each time. And it's a job shop problem, flow shop problem, so you have to run every job through all of these 8 machines. You can have additional views. So again, we created a very easy to make chart here which shows you which jobs are actually late. Now the question is, that's nice and integrated within Insight. What is if I want to have a new visualization myself? Is it also easy to integrate within the application? So the only things you need to do, you go to the Tableau designer, you just say, okay, give me a new chart, and probably what you want to do is you want to have 1 column per machine, you want to color them with by machine, and you might be interested in just telling you how much do I actually produce on each machine. So that would be it, and then I would probably call this sheet machine usage, and I like that one. And at this point, I would be done. Yeah, so I have created a new chart, and now I need to upload this to the server. You see, I just need to add this specific report, publish it, and I'm done. The only thing I have to do now is I have to close my application, I have to restart my application, and immediately I have my new report available, which presents the data in the format I would want to. So Insight has a great number of features, functionality built in, but even if extending it with external tools, with external component, we make this stuff very easy for you. So I think with this, I'm going to close the presentation, and we are opening the floor for questions and answers.
Great. Thank you so much, Oliver and Horia. And just a reminder for folks that if you do have a question, to go ahead and type those into the Q&A panel at the bottom right-hand corner of your screen. And we'll take a few minutes to answer your questions. And it looks like we do have one question there.
Hi, yeah, so this is Horia. The question is, suppose I have an existing Express Moselle model. What do I have to do to use it within Express Insight? So the process is pretty straightforward. If you have an existing Moselle model, depending on how you've used the features in the language, you would either be able to directly upload it by making by adding the Insight module to your model, or if the model combines a lot of declaration sections with a lot of scripting sections, you might want to reorganize slightly in order to put all the declaration sections together. And what that allows you to do, it allows Insight to automatically detect the structure of your constraints and variables, and therefore manage the model. So at the very lowest level, you're able to take an existing model, but if you want to fully manage the model, you may have to do a slight rewrite and reorganization of the code. Okay, we have a question. Is it compatible with other solvers? No. So the Express Optimization Suite is designed to be a complete modeling, optimization, and business analyst interface. So we are obviously competing with other solvers, therefore that option is not available. Okay, there's a question about what kind of licensing schemes do you offer? So there's a tremendous number of variations on how we can license Express, everything from user desktop-based development licenses all the way to enterprise licensing and everything in between. So please reach out to us for more information. We can provide that more detail as we discuss with you your specific needs.
So
okay.
The next question.
Yes, Oliver?
Okay, the next question is, how hard is it to dump charts from Insight to a web page for public consumption? So the built-in charts currently remain within the client, so you can share the scenarios. That's pretty easy. We've started working on a web client, and in this web client you can also share again with your colleagues. But the main way of sharing charts at this point is if you have created them in Tableau. We are using Tableau Server, and this is a full web application, so you can easily share your reports using that technology.
To add to Oliver's point, if you can create for example, a very limited user perspective within Insight, which offers a read-only perspective into a scenario or a set of scenarios, then you could simply offer that capability using the web version of Insight. So you would create, let's say, a read-only user, and when that user logs in, they have access to all the relevant charts and scenarios that were built for that project. So that would be another option to distribute charts. A question regarding filters, and the question is, when creating standard charts, can I reuse filters I've created when logging in again into Insight? Yes. So in Insight you can create dashboards. We've only just scratched the surface today. You can create dashboards, and within those dashboards, everything is saved. So the filters you apply, the aggregation levels you apply, the charts you construct, the specific data you may have filtered or aggregated, the actual layout of how you look at these windows side by side, all of that can be rolled in or saved as a dashboard. And so that dashboard is always available when you log in, when you log back into the application. So yes, we persist that information.
Great. Well, thank you so much, Horia and Oliver, for a wonderful presentation today, and thanks to all of you for joining us. This does conclude our webinar today, and again, we hope that you have a wonderful rest of your afternoon. We will be making the recording available to everybody that did register for today's webinar, so you'll be able to see that follow-up email come in within the next day or two. Thanks again, everybody.